message. The future is not set.
All right, so welcome to my session. Today I'm going to talk about the potential risk of using Terraform providers or Terraform modules in a cloud environment. But before we jump to that, I would like to introduce myself. So my name is Uri. I'm the CTO and co-founder of ZSecurity. I have spent over decades working in the cybersecurity, specializing in both offensive and defensive security practices. As a former security architect, I've tackled countless of security challenges in my career, and some of them I would like to share with you today. So the agenda for today, we're going to talk about Terraform, specific for Terraform modules and providers, and why we should evaluate any tools that we want to use in the organization. Then I will share with you some analysis we perform on those providers modules from a vulnerability perspective. And after that, we're going to talk about why we should take care of that and what is the impact of those risks on your organization. And next, I'm going to show you two attack scenarios. One of them will be involving vulnerable providers, and the second one will be malicious modules, and how this could be a significant risk for your organization. And last, it's what we can do to prevent it or even to reduce the risk. All right, so as a security architect or security engineer, your main goal is to make sure your organization is secure. To do that, sometimes you need to read the documentation for the tool to understand how it operates in your organization, if there is any potential risk there. In this case, I'm talking about Terraform. Terraform is a powerful tool that helps an organization specific for DevOps and SRE to manage the cloud resources by code, or what we know as IAC. What caught my eyes here was this section from HashiCorp documentation. By the way, they did a great job about document everything. So in this case, Terraform configuration will have full access to the variable and Terraform state. And other than that, Terraform cannot prevent a malicious provider's module from exfiltrating the sensitive data. Other than that, they also recommend to use only a trust module and provider in your Terraform configuration. That raised me a few questions. First, what is Terraform providers? The second one, of course, is what is Terraform modules? And how can attacker exploit this to their purpose? So let's understand what is Terraform providers and what is Terraform modules. Terraform is based on plugging, called the provider, to interact with a cloud provider, a SaaS provider, and other API targets. Each provider defines a set of data, resource type and data sources that help to Terraform to manage the resources. In other end, modules are a combination of TF file that located in the same directory that help the user to define what kind of configuration resource they want to deploy to the cloud environment. So actually what happened when user want to create a new resource, it will create a TF file, what we call also modules, with all the configuration want to apply to the resource. Then the Terraform core will translate it to the Terraform provider, and the Terraform provider actually will transmit the task to the cloud provider. From attack surface perspective, it's interesting because Terraform provider is written in a Go language program. The communication between Terraform core and the Terraform provider is based on protocol RPC. And the communication between Terraform to the target, Terraform provider to the target, is HTTPS. And I'm sure all of us know how many vulnerabilities each one of the components has. So again, Terraform is a powerful tool, but it's not bulletproof. And let's be honest, in this scenario, we need to take care of this attack surface because it could be very dangerous for the organization. But before we jump to the risk analysis we perform, I would like to share with you how HashiCorp manage those providers modules. So HashiCorp have 3 different tiers. The official one is owned by HashiCorp itself and that develop providers and modules. And the second one is the partner. Other companies that develop their own providers modules, but they have some partnership with HashiCorp itself. And the last one is community, is individual contributor that develop their own Terraform providers modules. Another interesting part here is that each one of the providers modules that part of those tier are also public accessible in a repository in GitHub, which means everybody can read the code, everybody can hunt for a vulnerability and review the code, and even if they do a great job, they can do a step further and inject some malicious code. All right, let's talk about the analysis we perform. So we tested closely the 10 widely used Terraform providers and modules from each one of the tiers I mentioned before. And what we found was all of them have some critical vulnerability. The highest number was in the community, which it makes sense because the individual contributor, probably they take care less of the vulnerability. But it doesn't mean the official partner is not risky for us, because still, when we're talking about 11%, almost 12% for the official one that has critical vulnerability, and almost 30% for the partner. Again, even if it's a critical to if it's hard to exploit this vulnerability, it doesn't mean we don't need to take care or to understand what is the risk of that. Now I have a question for you. It's a tricky question. Does having more non-vulnerability make you more or less secure? For I think it's a tricky question, because in my opinion, when you have a more vulnerability, maybe it's because the owner or the organization trying to hunt those vulnerability in order to fix those. And if you have less, maybe the owner or the organization are not checking for a vulnerability. This is why I think it's a kind of tricky. So, but I have another question for you, and feel free to raise hand. How many of you know using Terraform in production? All right. How many of you know which Terraform providers modules you are using? All right, and the last question, are you scanning those for vulnerabilities? All right, so let's understand why I asked those questions. So we took a closely look on the community, which has the highest risk, and we tried to figure out how many downloads they have, like how many users use those providers modules from the community. So what you can see here, we're talking about millions, and this is only for 1 month. And think about it for 1 second. 1 month, and we have million downloads, which mean every download could be introduced for attack for an attacker's side. So this is like a huge number. And this is another reason why we need to take care. And of course, it's also a reminder to understand what we're pulling to our environment. So why it's important? As you seen before, like the slide before, we're talking about millions, which means it's a kind of a cold mine for attackers. Because it's very attractive and a lot of users use it, it could be that the attacker will try to exploit it or to use it to manipulate the users. Another spot is a kind of a blind spot for application security processes and SDLC. Somehow, as you see, almost none of us raise a hand, take part of scanning the providers' modules for some vulnerabilities. And last, all of us, I'm sure all of us know how manual and expensive it is to fix things, and it's consuming a lot of time, and it's not efficient. So I share with you about Terraform providers. I also share with you some analysis we perform on those both Terraform providers and modules, and what are the risks of that, and why we need to take care of that. Now it's time for the fun part. I'm going to share with you two scenarios. One of them, how can attacker exploit a vulnerable provider? And the second one is how can attacker manipulate the user to install malicious Terraform and install some backdoor there. So in this case, I'm going to share with you a CVE from 2021. Even though it's a bit old, the reason I decided to share with you is because I faced it just 2 years ago. And it was very close to be in the production, and lucky for us, we managed to find it in time and prevent it. So the vulnerability itself is part of the Vault provider, which, if you remember the tiers that I mentioned before, it's the official one. That should be more secure or trusted. So the risk here is that the Vault provider didn't map the bound labels correctly, which caused some unauthorized access to some service account from GCP. Let's see in reality how it will work. So the attacker obtained a read-only access for some service account. If we are talking about previous attack, we know that that many of the attacks that happened recently obtain tokens from some public repository or S3 bucket that was open to everybody. So this step, it's kind of easier for the attacker. Next, the attacker needs to identify that the user defined Vault by Terraform itself. In this side, by the way, the user acts as it should be. Define the bound service account. He also defined bound label, as you can see on the top. But what happened when he executed the Terraform apply, the Terraform provider, the Vault Terraform provider, took it, the bound label, and map it to a non-variable, which make it the bound label empty. In this case, when the attacker identified that the user used the Terraform Vault to authenticate, he just needs to use the token that he obtained from the repository. And even if he didn't have any access to that, when he will authenticate with Vault, surprisingly, we get access. From this point, what you need to do is just to authenticate with gcloud, and he will get access to the admin role. And from this point, he can do whatever he wants. He can do lateral movement, data exfiltration, and service disruption. You name it. Another interesting part about exploitation, specific in the Terraform provider, because it's public accessible to the internet, if you will go to the provider itself and search from issues or some security issue, you will find a lot of new security issues there, or old. Some of them open, some of them closed. But the interesting part here, a lot of them are not associated with any CVE. Which means if you will scan those providers for vulnerability, you will miss it because they don't have any CVE. And this is another reason why we need to review the code, review the issues to understand if they close the security issue or not. All right, let's jump for the second part, the malicious modules. So in this case, attacker can upload a malicious module to Terraform registry or GitHub. He has a lot of options to convince the user to install it. Could be a local path, Terraform registry, GitHub, S3 bucket, and so on. In this example, I'm going to show you a Terraform module that creates an EC2 instance that should be it will look very normal, nothing suspicious there, but in behind the scene, it will use user data from AWS to inject the backdoor. If you are not aware of the user data, what user data is the kind of a feature that AWS helped to DevOps to install some software and components before in launch. So in this case, the attacker used their social engineer to convince the user to install the malicious modules. Once the user install it, you will use it, as you can see in the bottom, import the malicious modules. And after and there is nothing malicious, look malicious, just the word malicious, but in reality, you're not going to see that. So the user create the EC2 instance, as the module should do. And if we execute the Terraform apply, once you do that, he basically not only create the EC2 instance, but he also create the access to the attacker. How the malicious modules looks from the attacker side, it looks exactly like that. Still, nothing malicious because he obfuscated all the malicious stuff in base 64. And another important thing to say here is in my career, I've seen many DevOps team and SRE use base 64 to encode user data because it makes the code much more readable and easy for them to manage it. So we talk about two attack scenarios. One of them involved in a vulnerable provider. The second one involved in malicious modules. There is another one, but unfortunately we don't have time. It's a malicious provider. But let's talk about what we can do to reduce the risk. So the best practice, read the documentation, read the code, try to review all the issues that you have there, and try to scan those repositories for vulnerability. Even if they have a lot of vulnerability, it's good to understand how the owner take care of that. If they have a vulnerability, for example, for a long time, which means probably the owner doesn't care about that, so it could raise a flag there. Version pinning. Pin the version of your provider to reduce the possibility of introduce vulnerability. Terraform lock HCL is where you can find all the versions from Terraform providers. So you can keep tracking the version that the Terraform provider has there, and you can also scan it with some open source tool to understand if you're using the latest version or not. Another important thing is to enable the state locking. State locking is kind of mirror what the user do with Terraform and what Terraform apply on the cloud. Which attacker have access, when attacker have access to it, he can manipulate the state file and cause a lot of problem to your infrastructure. Keep auditing and monitoring your Terraform plan and state file, and and try to identify some unexpected changes specifically in the state file. Scan your configuration with IAC tool. That will help you to prevent some misconfiguration that deploy to the cloud. All right, what about mitigation? You can also implement some control to reduce the risk, to help you to kind of minimize the exposure or use some high privileges in your environment. So, for example, you can protect the CI/CD system, application log, and especially the state file by using IAM role and give a Terraform just least privileges and use only the temporary credential rather than the log leave secret. You can use a network restriction like VPC, load balancer, and WAF to enable only non-communication between services. You also can use CWPP, SAS, to prevent non-malicious communication from your infrastructure. And last, you can use CloudWatch, and this is specific for AWS, to create alert to detect if someone tried to read your state file or to do some manipulation there. Question? All right. I think. Oh. Yeah, 1 second, I will give you them.
What scanning tools do you recommend for your?
All right. Yeah, that's a good question. So there are tons of open source that you can use to scan those. I really like for repository to scan with Rivi, if you're familiar, part of Aqua repository. For IAC, you can use Chekhov, and There is another tool called Claire for detect for images, if you want to scan those. There are a ton of tools, like I can share with you later on if you want. That's it.
Are those tools seeding Terraform modules and providers, though?
No, so Chekhov scanning a Terraform file. Trivi can scan the repository where the providers and modules are located. Okay, so any other question? All right. All right, thank you guys. Thank you very much.